Good afternoon, everybody. Welcome to the IBM Power 11 webinar. We are just giving some people a few minutes to join, so we'll probably give it another minute before we start. So bear patience with us, and we shall start shortly. Well, about another minute, minute and a half we'll give to the rest of the participants joining. Okay, I guess we'll get started. For those joining, Um, Liz will let you into the room. If you're in the lobby now, somebody will let you in shortly. So just in the interest of time, I'd like to start off with welcoming everybody. Good afternoon, everybody, and welcome. And thank you for joining us for today's session. IBM's Power 11 called The Perfect Storm for today's data-driven mission critical workloads. My name is Iqbal Khan, and I'm the founder and managing partner of FAHM Technology Partners. For over 20 years, we've had the opportunity to work with organizations designing, modernizing, and supporting mission-critical IT environments at FAHM. Our focus is helping clients build and optimize enterprise infrastructure from compute, storage, and virtualization to cyber resilience, hybrid cloud, and data center transformation. As a strategic partner within IBM ecosystem, we work closely with CIOs, infrastructure leaders, and enterprise architects to support some of the most demanding workloads across industries where uptime, performance, scalability, and security are non-negotiable. That's exactly why we're excited to host today's discussion around IBM Power 11, a platform engineered for the next generation of data-driven and mission-critical infrastructure. That's exactly why we're excited about this today. But before we begin, I also want to acknowledge Mr. James J.O. Stout from IBM, who was actually originally scheduled to help lead today's session. Unfortunately, due to some personal emergency, J.O. is unable to join us today, and we certainly send him and his family our best. Jo is a senior power sales manager at IBM with over 22 years of experience helping organizations across healthcare, manufacturing, entertainment, and distribution, and unlocking business value through enterprise hardware, software, and services. While he couldn't be with us today, we appreciate his support in helping bring this session together. Now I'm pleased to introduce our key speakers for today. Firstly, Bruce Turgeon from FAM Technology Partners. Bruce brings extensive experience in enterprise infrastructure over 32 years, IBM Power Systems, hybrid architecture, and helping organizations align technology investments with long-term business outcomes. Joining Bruce is Mr. Glenn Corneau from IBM. Glenn brings more than 30 years of deep technical expertise across AIX, Linux, hybrid cloud, and IBM Power environments, helping organizations modernize and optimize their most critical infrastructure platforms. Bruce and Glenn, thank you both for meeting us, being here today, and I'd like to hand it over to you guys to continue the session. Thank you so much.
Thank you. Yeah, let me explain to you why this is the perfect storm and how IBM Power Systems are both built for today's challenges and one of the best kept secrets. Mission critical. Mission critical refers to any system, process, or component essential to an organization's core operations, where failure would result in severe consequences, including financial loss, operational disruption, or even loss of life. According to the survey on the right there, by 2026, we're supposed to achieve 20 trillion US dollars in loss due to cybercrime. So it's pretty significant as a worldwide number and something that we're all considering when we're thinking about our mission critical business that we've created. So IBM Power Systems has always been strong in the area of mission critical, like high availability, disaster recovery, fault tolerance, self-healing. But what's been evolving over the recent generations of IBM Power Systems is the cybersecurity. So specifically with Power 11, we're getting more into prevention, protection, detection, correction, and recovery. Second component is data driven. The volume of data is ever increasing and very important to today's business. The global data sphere, according to IDC, is going to hit 175 zettabytes by 2025. That's 1 billion terabytes, if you're not sure how big a zettabyte is. Power Systems has always been strong with relational databases, data, doing AI inferencing since Power 10 has been built in, and quantum safe encryption, which has been built in since Power 10 as well. But the key here is that you don't want to be shipping your data all over the place to do your analytics. You want to do the analytics, and the AI workloads where the data resides. So at the source. So that's key with IBM Power Systems is keep it all local. The Power 11 product line spans from edge computing to cloud computing, and very key is the hybrid architecture. So we have a scale of Power 11 servers with the Power 11 processor, spanning from small 2U servers all the way up to large enterprise systems. And then on the right there, you'll see Power VS. That's our Power Virtual Server. So this is a cloud offering through IBM where you're paying for just the virtual components that you're utilizing in the cloud. This is perfect for development or for disaster recovery. So a good combination with your environment to include both on-prem and off-prem in the cloud. So what's new with IBM Power Systems? And this is key when you're looking, if you already have Power Systems today and you're looking to move forward from like Power 8 or Power 9 to Power 11, is to what are the additional features that have been added that you can take advantage of to both improve the return on investment as well as up your security. So really, IBM Power Systems are built for data processing and for large scale server consolidation, where you can really save a lot of money on software licensing. With extreme memory bandwidth, we have 4 terabytes per second that we can of data we can push around within the system. So as far as hardware virtualization goes, there's enterprise pools, which the newest generation was available with Power 9 and has evolved since. And then subpools have been somewhat replaced with resource groups now, a way of sharing the resource within a server for a particular application like Oracle database and being able to reduce your license count. It's a Unix-based power processor that's in these systems. So right from inception, this server was built for multi-user support. It's also built to do high scalability. It's got built-in security and reliability features. New to Power 10 and 11 is the quantum safe encryption. So now encrypted data at rest on your disk as well as active within the memory. And we'll touch on this a little bit more later, but this is key to protecting yourself against any kind of cyber attack where they're going to steal your encrypted data. Uh, Integrated technology. So Power Systems, is one of the leaders in this area of combining everything that you need into one package. So from the firmware level up, security, uh, recently added threat detection and remediation. It's had self-healing for quite a while, inferencing with the built-in AI accelerators, has HADR capabilities, and recently added zero downtime. AX is a rock solid operating system, and interestingly enough, It's had Linux affinity since AX5L that was introduced in 2001. So you can run Linux commands and get response back on the system as if it was a Linux server as well. So it really helps people who are also Linux admins to understand the AX operating system. But there's a lot of commonality between the two. And then IBM I is the fully integrated uh, application and software stack. If you know, you know. A lot of people are taking advantage of the IBM I, and now it has new simplified bundles of software as well. And we also run Linux. It's not a special flavor of Linux. It's Red Hat Linux, Red Hat OpenShift, SUSE are all certified to run on these systems. Uh, IBM acquired Red Hat in 2019, so really that's part of the same company now. And IBM has been a top five contributor since the 1990s. A lot of what's in AIX that makes it rock solid has been ported over to the open source community and in the Linux kernel. So when you're running Linux on Power, I believe it's the best place to run Linux because of this integration. So it's actually the OS being able to talk to the service processor. So, and it also takes advantage of the performance, scalability, and availability and security of IBM Power Systems. So as an example, what you can get on a Linux system is the black screen of death. That's where it's really a kernel panic. It's where things like memory got overwritten, and so now you can't retrieve it, so the system has to crash in order to preserve the data. So with the abilities to be able to intercommunicate between the operating system and the service processor, we can do a lot of self-healing where we can correct for that. And in particular, for the memory overwrite, uh, we included the memory fencing features that we had in AIX, which protect memory between applications and don't allow cross-contamination. So this is the roadmap of processor technology that we've had over the time. And you'll see that like Power Virtual Server has been around since 2014. And enterprise pools, which the latest version is PEP 2.0, was introduced with Power 9 and has become more and more an important component of designing your systems. 2021, 2022 was Power 10, where we had in-core AI acceleration, which continues into Power 11, as well as the quantum safe encryption. And now with Power 11, we've got 6 nines of availability. Let me just talk a little bit about cyber attacks and how IBM Power Systems is actually positioned here. So operating systems targeted for ransomware attacks, 87% is Windows, 7% is Mac OS. The 6% left over is a combination of operating systems, primarily Linux, but also AIX, IBM I, ZOS, etc. So if you look at the number of successful data breaches on the right here, you'll see out of that 6% for Linux, 84 successful data breaches was on x86 based Linux server. One was on an IBM Power server running Linux. And we've had 0 known breaches with IBM Power running AX or IBM I. And you'd think that maybe Power Systems isn't being used as much, but actually Power Systems are in 95% of the Fortune 500 companies and are typically running mission critical databases on their back end. So when you're looking at implementing servers, one of the things I sometimes get from people is they don't have a skilled person to manage AX on a power system. So this is kind of a look at what the workforce is out there. 72% are Windows knowledgeable, 13.6% are Linux, 5.6% are Unix, and of that, most of that is AIX. today. But the key thing to keep in mind here is you can easily train somebody who's a Linux admin to be able to administrate Linux on Power or AX on Power. So it's actually an advantage here if you try to build the resources you need to manage these systems because they're less targeted by cybersecurity attacks. So I'm going to pass it over to Glenn.
All right. Thank you very much, Bruce. You want to go ahead and advance the slide there?
Yeah.
All right. Well, as Bruce already kind of laid out for you, of course, Power 11 is the latest generation. Both Bruce and I have a long history way back into when Power didn't even have a number after it, and so that kind of speaks to the resiliency and the reliability of that platform, as you know. IBM being one of the few vendors that not only develops the silicon, the CPUs, the servers, the firmware, and the operating systems, and integrates it all back up into the cloud. So Power 11, stands on some very tall shoulders, and we focused on a few key items here that I'm going to cover. Bruce already mentioned, this whole concept of zero planned downtime because of course in every world today, as you administer our systems or other systems, you do need to have maintenance applied. You do need to patch security fixes and things like that. Um, Thankfully, none of those known security breaches, happened on AIX or IBM running on Power. But of course, we still need to definitely guarantee protect against those kind of ransomware attacks because the evildoers are out there and they want your data, and anything they can do to get your data and or kind of hold you for ransom to pay for your data back, they're going to try and do that. So with the new capabilities with IBM Power Cyber Vault, we can have very very fast detection, less than 1 minute, and an automated quick response and recovery within just a few minutes. And of course, as Bruce mentioned, with zettabytes of data or zottabytes, whichever it's called, you don't want to be moving that all around. So being able to bring the AI processing directly into the processor and keep it close to your data means you can speed up those AI integrations into existing enterprise workflows. Next slide, please. Okay. And it really all revolves around total business continuity. Of course, as mentioned, the reliability, availability, and serviceability that we've had in the Power platform over decades now has led us to the point where in the Power 11 generation, as Bruce mentioned, we went from 5 nines to 6 nines of availability. And if you do that math, that comes out to less than around 31 seconds a year of unplanned downtime. So the hardware, the firmware is very reliable. But as mentioned, of course, you do have to maintain these systems. You do have to sometimes take them down for disruptive maintenance. We've certainly done a lot on the hardware side with the ability to hot add adapters and things like that over the years. But eventually, there's going to be some kind of disruptive maintenance. So one of the key pillars of the Power 11 platform is this concept of zero planned downtime. And so we're going to talk more about that in greater detail. But security is that overriding factor that everyone is concerned with today. So you know having protecting you from cyber incidents is going to be key. And it not only starts at the hardware, a secure by design system from the processor on up, but of course, the buzzword today is quantum safe, and we're going to talk more about that because that ties in not only with protecting your data today, but protecting your data in the future. And as mentioned, Power Cyber Vault is gonna help you with the actual detection of ransomware in your environment and recovery. Next slide, please. So when we talk about zero planned downtime, it's really the amalgamation of key features that we've added into Power 11, both in the server as well as the virtualization stack, the hardware management console, but also in conjunction with another part of IBM, specifically some software called IBM Concert. Now, IBM Concert is a software package that we use for doing AI-based detection and orchestration of patching of power systems. Now, it does work on other platforms as well, but we're going to focus on what it does for power today. As many administrators know, the job of keeping up with all the latest security vulnerabilities, and that's what the CVE stands for, is a never-ending job. If you're subscribed to IBM support, you probably get a couple emails a week on new CVEs that have come out. So products like IBM Concert keep track of all those CVEs. It helps you maintain an inventory of the systems and the components that you have in your environment and where they may be affected by those CVEs. And once you understand what you've got out there and what needs to be patched, you can rank a security risk to those individual CVEs, and then put into place a remediation plan to get out of the risk and into a safe space. So with the most recent release that actually just came out this week, we do support all the operating systems running on Power, so AIX, IBM I, and Linux. And we're going to see on this next page kind of what we do under the covers to help make it be a zero planned downtime configuration. Whoop. Thanks, Bruce. So as I mentioned, it's both the Power11 systems, the servers, the hardware management console itself. There's new technologies built into there to allow that HMC to be the focal point for actually driving patching of not only the virtual IO server, but the system firmware and the adapters that we've traditionally done from that endpoint as well. Now with IBM Concert, it can, again, discover the environments you have, discover what CVEs are applicable, put together a recommended plan of remediation. And if you so choose, you can actually allow the orchestration from IBM Concert to drive the patching of that given environment. I like to use the example of a disruptive system firmware update. If you have more than one system and you're designed in such a manner that you can do live partition mobility operations between those two servers, and you have the resources, Concert can drive through the HMC the movement of workloads dynamically and live, so zero downtime, the patching of those systems, and then the return of those workloads back to the original system based on the plans and policies you've put in place. So we're not doing any magic here. We're not giving you more resources than you paid for or anything like that. But in a well-designed and well-planned out environment, the zero plan downtime feature can really improve your overall system solution and availability. All right, next slide, please. Now, as I mentioned, quantum is all the rage nowadays. You hear about it all over the place. It's important to understand that IBM as a technology developer and a research firm, we also have been working in the quantum space for quite a few years. You've probably seen pictures of the giant steel columns that is our quantum computers. But we've also worked very much on the software side, specifically in the area of encryption. So today's encryption algorithms are basically really hard math problems that take conventional computers a long time to solve. And that's what makes your data safe, because it takes a long time to actually break that level of encryption on a traditional computer. With quantum computers, the traditional algorithms can be broken very easily, unfortunately. And so the current algorithms aren't safe. And so not only the governments, folks like the National Institute for Standards and Technology, they've put together 4 basic quantum algorithms that have been approved as quantum safe. So they really can't be broken by quantum computers because of their different design. IBM was key in developing 3 of the 4 algorithms. And in fact, the 4th researcher who was in charge of that last algorithm, he actually came to go work for IBM after it was approved by the government. So IBM is very much involved in keeping your computer safe, and we've used that injection of technology not only down on the hardware level. So our processors have support for what they call post-quantum cryptography algorithms, so it speeds up the ability to use those algorithms. As Bruce mentioned, we've got always-on memory encryption, so the memory is safe. As soon as it leaves the processor, it does not leave unencrypted. Our ability to move virtual machines back and forth using live partition mobility, that requires a network traffic, and we use quantum safe algorithms for that network traffic as well. As well as system firmware signing and secure boot capabilities for the operating systems running on Power. So we've really built in these quantum safe requirements all up the stack, and of course the operating systems and applications, they can use quantum safe libraries and cryptographic libraries as well to really round out the entire stack. Now, you may not be working with federal clients, here in the U.S., but as we know, usually when governments mandate certain levels of capability and cryptography, that flows down through your regulated industries and to your end clients, and we all want to be that safe and protect our data as well as we can. Next slide, please. So I kind of touched upon some of this already. The quantum safe firmware that is designed and built in conjunction with those NSA recommendations. The ability to protect your data across the wire. One of the methodologies that bad actors use is they go and they acquire your data today, encrypted with today's encryption algorithms, and then they're going to hold on to that so that at some point in the future, hope not that far off now, when a quantum computer is affordable and available to those bad actors, they can then use that quantum computer to break your old encryption and then use that data to find some business value in there and hold you for ransom, whatever it might be. So if you can implement the quantum safe algorithms today, doesn't matter if they even happen to get that hold of that data, they're not going to be able to do anything with it. So that's where using quantum safe encryption of live partition mobility traffic across the wire comes into play as well. If you write your own applications or you need secure key stores for those regulated workloads that might require that FIPS 140-2 level 4 capability, we have the cryptographic express card, which is a physical card that you can put into the servers, and it supports those quantum algorithms as well. But today, if you think about first steps, it's about what do I have in my environment? So we can use tools like PowerSC to run a quantum inventory scan on your servers. It will look for keys, libraries, and encryption code that's out there on your servers, and let you know what you've got in your environment, which of those algorithms are quantum safe, which of them are really not safe according to today's algorithms, and then you can put in a plan in place to get things upgraded and updated to make your entire stack quantum safe. And if you want to see that, your business partner can actually do a demonstration using the IBM Tech Zone resources of that. All right. And the third pillar, down there, in addition to keeping your system safe, is well, what happens if things do go wrong? And we've all heard stories. I'm sure maybe there's some of you who were at the Tech Exchange a few years back when the certain hotel brand that the Tech Exchange was happening at got hacked, and technologies like IBM Power Cyber Vault would have helped prevent that. Situation. So the National Institutes of Standards and Technology has a cyber guidance framework, and it is basically this 5-step process. First is identifying the risks you have in your environment. We kind of talked about that, being able to catalog all your security environments, where your data is stored, on which storage subsystems. But when you think about one of the ways that the ransomware attackers do is once they get into your systems, they'll encrypt your data using their own algorithms, and they have the key, and then they hold you for ransom. So at the storage level, IBM Storage can create what are called immutable copies of your data. And immutable copies are read-only versions of your data, and they are air-gapped. So they can't be modified, can't be changed. So with those, if you do it, once an hour, once a week, whatever your RPO, RTO objectives are, determine how often you store that. But we have that capability within IBM storage. And also coming from the storage is the ability to detect malware and ransomware in place in real time. So the storage itself, even down to the disk drive level, will detect that there's a high probability of ransomware being implemented on the storage. It will notify the controllers in the storage. That will notify the storage management software, and it will alert and detect. And if it is indeed a ransomware attack, implement a response and recovery very quickly. It does that by means of what we call the Cyber Vault Clean Room, which is kind of as it sounds. You can think of it as a space to the side where you can take a look at these copies of your data and the immutable copies that you've taken before, and you can find out which ones are your good copies and which ones are the corrupted versions, and you can roll back to the good copies very rapidly. That clean room can also be used for proactive validation of your copies. So as it takes these immutable copies over and over again, you're running regression tests and validation tests against that data. All right, next slide. And it's not just the server, it's not just the storage, but it's really it's a whole host of technologies that work hand in hand together. You can see some of them listed there. But it also includes the ability for expert labs or your business partner through expert labs to come out and help you design, implement, and test these kind of security technologies. And with that, Bruce, I'm passing it back to you.
Okay, thank you very much. Yeah, so I'm just going to touch on migration from older power systems to Power11 and architectural considerations. So some of the key architectural components which will help you optimize total cost of ownership is live partition mobility, shared processor pools, resource groups. As I mentioned before, kind of that's the new implementation, and the shared processor pools may not be needed as much anymore because it's more effective doing resource pooling. And then Power Enterprise Pools, the 2.0, it's the second version of this kind of implementation. I'm going to get into that more in a second, and as well as CapEx versus OpEx. So, this is fairly new to a lot of people, and it's been very it's been very beneficial for those that are using it today. So I just want to go over this. So it's like pooling all the resources you have on your systems all together, and they get metered by the minute. So you purchase how many activations you want, but all the cores in the system are on, and you pay for what you use. So if you're doing a cap X, so it's a capital expenditure, you're purchasing the cores that you need to do your business, and you're never going to be going above that. So it's metered by pool number one there on the right as your base. And one way you can effectively use this is for disaster recovery. So if I have this in production, I don't need to activate very many cores in my DR site. And when a failover occurs, it's all being metered in one spot. So if you're not using it in production, it's immediately available in disaster recovery. So your disaster recovery systems can come back up full, and you're saving on all those extra core and operating system licenses that you would have had to have purchased in DR. So it more effectively uses that and helps you reduce the cost of your systems. So another way of looking at this is CapEx versus OpEx. So for the operational expense model, you would purchase as few as possible core activations per permanency, but you would be metering and paying for what you use above that on a minute by minute basis throughout the year. So two different approaches to this that depending on how you are structuring your payments, whether you want OpEx or CapEx. So we have this 5-point plan to migrate from older servers to newer servers. You don't just decide overnight that you're going to move to the latest version. It should be an ongoing process to make sure that you are staying current with the environment you have. And with how well power systems run, you sometimes set them up and then kind of forget about them. And they're always running in the background. But we do need to do a reality check on them once in a while and make sure everything's up to date. So the OS versions, and then making sure your applications support the OS versions and all the patch levels. So at least like on a yearly basis, we try to look at best practices of what levels your environment's at, make sure you're staying current, and that will make moving to a new system much easier. And then 6 months out from a point where you'd be changing to a newer system, we would want to start collecting uh, performance data, like with HMC Scanner and some other tools, to look at what the usage is, because we might want to right size your environment. If it's over provision today, we might be able to get away with uh, a less costly system going forward. And then architectural considerations, like I just went over the PEP 2.0, OpEx versus CapEx, cloud, pools and groups, etc., are all things we want to consider in the architecture going forward, whether you're taking advantage of that today or whether you want to add some of those features going forward. And then we get into server sizing when it gets closer, using everything we've collected. And then how we actually do it is point five. How do we move the data, the operating systems over? And then I also want to touch on this security and resiliency assessment workshop. We call it SARA for short. And what that does is it's a technology agnostic maturity assessment for your environment and how well you are positioned for cybersecurity and security in general. And uh, also, it helps drive a better cross-team understanding of security resilience requirements so that all members of the team, like the storage division, the server group, are all on the same page. And also helps you prioritize where you want to invest in improvements. So going back to Glenn covered this, and I kind of mentioned it right at the beginning. This is all built around the NIST cybersecurity framework. It has governance wrapped around that. And then each of the key areas is identify, protect, detect, respond, recover. So these are the kind of things we go over during the assessment. And as attendees in today's webinar, uh, we're offering you this SARA assessment. So I'm going to pass this back to our leader.
Hey, Bruce, before we
Yeah.
do that, we actually did get some questions into our queue,
Okay.
if you'd like. And I've got it pulled up here, so I think most of them are for me anyway. But if you have any additional things to add, you can go ahead and add those to them. Pardon me if I say your name wrong. I'm going to say Erman, but could be could be pronounced differently. He did make a comment that in many cases customers are not ready to apply the latest patches or CVEs, and that is certainly true. At least with tools like IBM Concert, and it will help you at least keep track of what you should be applying, and generate a risk statement that you can have your customer or your customer's management sign off and say they accept the risk for not applying those patches, and then at least there's some documentation there in play.
Yeah, I think
Uh,
this came from where you were mentioning that it could auto detect when you need patches and have them applied. But yeah, the
yep,
key point there is you have to accept that and install them.
yep. In the case of like an MSP type situation where there's a lot of older generations of hardware, and again, boy, that just speaks to the reliability of power. If you're talking about power 6, 7, and 8, there, we all know, yes, there's customers out there with systems running of those older generations. Unfortunately, the IBM Concert solution does not support below Power 11 today. I know there is a plan to add support, or actually, I should take that back. It supports Power 10 and Power 11. It will only orchestrate fix installation on Power 11 today. There is a plan to extend that capability to Power 10, but nothing further back in time from Power 10. So yeah, you'd have to keep track of those the old-fashioned way, if you will. The third question was about live partition mobility and how long it takes using encryption. So we've had actually encryption built into live partition mobility since Power 10. We've had those capabilities there. And so it with the in-core silicon that we have that actually accelerates encryption and decryption, while there is a delta, it's not as much as you might think. I'm not sure we publish any real numbers on that. I'd have to go back and look at one of the red books probably to see if somebody has put some actual tested numbers in there. But certainly having the CPU processor with the encryption, decryption, acceleration is going to help that for sure.
Yeah, so I think it just add to that, just like including virtualization, like the power systems are all virtualized, and the encryption is standard on the system now. So when you look at benchmark data comparing the performance, those are all enabled and on. It's not like we show the performance with all that turned off and then turn it on later. So there's not, when you look at the performance numbers, benchmark results, the relative performance, those are all with all these features enabled.
Yeah, IBM's been very good about that, especially power. And if you think back to the Spectre meltdown days with side channel attacks
Mm-hmm.
and things like that, all our patches that we installed, we saw very little performance degradation installing those patches into our systems. And they all run with that turned on all the time. So yeah, all our performance numbers are built like that. I believe the last question was about SFTP and some other programs running on IBM I think that kind of falls into the same boat as what we said before. Some of those technologies are all built on things like OpenSSL. And OpenSSL, we have upstreamed code into those libraries to take advantage of the IBM Power architecture, and or the chip architecture just automatically accelerates some of those same mathematical operations that could be common for encryption, decryption, whether it be on IBM AIX, or Linux. Thank you for the questions. They were great questions.
Great, thank you, Glenn. Was there any other questions you guys have, Bruce or Glenn, in the repository there?
Yeah, there's you talked about quantum safe. Does this mean I need to have or have access to a quantum computer to be quantum safe?
No, thankfully. That's good.
Mhm.
No, you just need to utilize the quantum safe algorithms. You don't have to have access to a quantum computer to test those, unless you're a hacker trying to do some bad things or you're a developer of quantum algorithms. You don't need that access.
But I think what Glenn mentioned when he was presenting too was cybersecurity. The attackers are looking to steal your data, even if it's encrypted, in the hopes that they can decrypt it once they get a quantum computer. So they're hoping to get to something that could break that encryption. And that's why quantum safe encryption both has classical encryption as well as quantum encryption built in, so it can't be broken by either type of system. Another one for Cyber Vault. Do I need duplicate storage hardware for protection and recovery?
Uh, Great question. The answer is no. So the IBM flash system and DS storage all have this concept of immutable copies built into the hardware itself. So you don't have to buy a whole second unit where you copy the data back and forth to generate those immutable copies. You can do that within the same storage unit that you already have.
Cool. So does zero plan downtime imply a guarantee that the system will never fail?
No,
Okay.
no one can ever guarantee. As
Yeah.
they say, hardware eventually breaks, software eventually works, right? No, it's not a guarantee, but it does help you maintain the business continuity when you need to take those systems down for planned outages.
Okay, great. Well, thanks for those questions. Really good and informative session, guys. Thank you, Bruce and Glenn. And thank you, everyone, for joining us today. We hope today's session provided valuable insight into how IBM Power11 is helping organizations strengthen performance availability, cyber resilience, as we talked about, and long-term infrastructure strategy. As a next step, as Bruce outlined, our team at FAHM here will be reaching out to schedule a security and resiliency assessment, which is what we refer to as the SARA workshop. This personalized session is designed to help assess your current environment, identify infrastructure or security gaps, and explore practical modernization opportunities aligned with your business objectives. So, probably going to need an hour of your time. We'll set up an initial session to kind of identify what will be needed and who will be needed on the call to be able to do that. And then we'll be able to provide you your blueprint, and that's free of charge. And it's a value of you attending this seminar today. We look forward to continuing this conversation with you as next steps. And thank you again for your time and have a great day, everyone. I do see one other question. Okay, thank you guys.
Thank you.
Yeah, thank you.